Hi guys, Mr. Shaw here. This is day 4 of the online video learning. Couple things as we go through this. So one of the things is I am not going to give you an actual assignment today, even though it says that on the homework right there. I just want to make sure that you're watching this video. If you're watching this video, all you need to do is in the online assignment that I'll have in there, and just type in the number 107, and I'll know that you watched this video, and then you get credit for it. All right, so I'm going to keep this a short 5-minute presentation. We're probably not going to get all the way through the rest of the advanced components, but just want to make sure that you're aware of what's going on there. Tomorrow on Friday, I'll put the last part of this presentation on there, as well as a couple of questions. All right, so getting into this, we talked a little bit yesterday about some of these advanced components, including showing you a capacitor blowing up a watermelon. So what capacitors are is they have an ability to store and discharge electrical charges. They come in various different sizes, but essentially what's going to happen when you're taking a look at them, let me put my pointer on pen. So this is essentially what a capacitor is. You have two parallel plates, literally metal plates that are separated by a distance. And sometimes you'll have in between some sort of insulating material that stops those two plates from touching. We generally measure the units in farads. 1 farad is really big. Give you an idea, typically we measure the values in microfarads, nanofarads, or picofarads. Basically 1 million, 1 billion, and 1 trillionth of a farad. If you ever come across a capacitor that has 1 farad and that is charged, do not touch it because it will hurt you pretty badly. The old CRT TVs, the cathode ray tubes, those are the really big TVs that they had back like in the 90s, back when I was growing up. They had these large capacitors in them because that was what allowed them to turn on. So one of the things I remember when I used to have to work on them, you took a screwdriver whenever you'd open up one of these old cathode ray tube TVs, and you have to put that screwdriver across the two tips of it. That way it discharged all the electricity. Because it's kind of crazy how much will build up in there. So what happens is once you have a battery in place, all these electrons are going to want to go to one side of it because they want to try to get to the other side. So as soon as you have a voltage source being put on there, it actually starts charging it up. All right. Now the nice thing about capacitors, they'll discharge very, very fast. Here you can see different types of capacitors that we have. Over to the top side here, these are more the larger ones. You can see 2,200 microfarads. These ones are a little bit smaller over here. These ones look like they're in the nanofarad range. Yep, nanofarad range. But here again, you can see we have 1 plate, 2 plates separated by a material. Now, the way that we show them in diagrams, typically either like this one just means it has a positive and negative side to it, or sometimes you'll just see it as 2 parallel plates like this. Now, you'll notice this is slightly different than the battery, and different in the sense that they're both going to be shown as the same length itself. So in this case right here, if we had voltage being applied, what's going to happen is this is going to start to get charged up. Now you are going to allow this to be charged up. This LED, all right, this LED is actually going to turn on because it's allowing the current to go in that direction. All right. It's going to charge up. So no actual current is actually going to be flowing through here, though, because remember, there's nothing here that allows those electrons to jump through that's going to allow them to go through there. But what happens is if all of a sudden we take this and we get rid of this, what's going to happen is all the charge that's built up inside here is now going to want to get to its rightful place. So all those electrons that are built up are now going to come up and pass through. In this circuit right here, what we're seeing, this is actually a traditional fader circuit. So this is the idea when you turn off a button and you start to see that LED slowly fade away. That's what's happening. There's some charge built up on a capacitor that is slowly discharging itself, so it's not a quick off. It's just slowly letting it go off. All right, next thing, diodes. All right, and we're going to go through diodes, and that's going to be it. All right. So diodes, when you take a look at it, they only allow current to go in one direction. You'll notice right here, it's a nice little arrow that is showing you. So go figure, it's only allowing current to go in that direction. You also notice that if you try to see if current's going that way, it's going to hit this line right here. Imagine that that's a wall and it stops it. So in the ideal world, it allows current flowing forward. It prevents it from flowing backwards. Doesn't allow it at all. So in this case, since our current is going from positive to negative, it would allow it to go through. All right, so this circuit would indeed be on. Now, there are many different types of diodes out there. There's the basic diode that's literally just like a one-way valve, only letting current going in one direction. Then there's also something called a light emitting diode, LEDs. I'm sure you guys have heard of them. These ones emit photons when they're energized. Photons are just light energy. They use very little power and they last longer than a typical light bulb, hence why they're used so widely right now. They still do create quite a bit of energy or thermal energy coming off of them, so you do have to cool them off, but they're a great alternative. And when you see the symbol, it's going to look like this. You're going to see an LED, and then you're going to see two arrows signifying that light is going away. All right. Next type are photodiodes. These allow current to flow when exposed to light. All right, this type 1. Type 2, it actually generates voltage when exposed to light. These are all used in solar panels. All right, so here you can see the two different types. As the light comes in, it allows current to flow. And this one, as the light comes in, it actually generates a voltage. So these are like in the solar panels. These ones over here are kind of more what you would see if like a light sensor, whether or not something's going to turn on or off if all of a sudden it loses light. Alrighty. Yeah, let's go through this one really quick. All right, diode use in AC power. So we know AC and DC, there are different types of power. AC is obviously alternating back and forth, back and forth, back and forth. DC, one steady voltage. So we can actually use diodes to help save ourselves with this issue. So if we want to convert back and forth between one another of them, so right here you can see this is my input voltage. So this is your typical AC power. Ooh, I'm doing an awful job tracing that right there. Now, if I was to run it through this diode, it is only going to allow it to go when it's in the positive region, right here and right here. So what you're actually going to see on your output side over here is you're only going to see it moving in the positive direction. As soon as it starts to go negative, it just doesn't allow anything to happen at all. So there is nothing transmitting through. Over here again, it's allowing it to pass through. Here, nothing. That is essentially what is happening. So AC is very useful for working with it. Now here you can see again, we have that same idea. It's passing through. This is called a simple half-wave rectifier. And this is something you don't have to memorize, excuse me, but it is kind of useful information. Now, if we want to keep it at steady voltage, what we can do is we can also take a capacitor, place it in there as well. So what happens is as that current is going through here, it's charging up that capacitor to the same voltage. So it comes in there, charges it up. As soon as it does not allow our voltage to go in the other direction, now we're using our capacitor. Obviously it discharges a little bit over time, but it gives us a more steady current. Now, if I wanted to go even crazier, I could do something called a full wave rectifier. This is actually one of the things that I worked on when I was in college for my final project before I graduated. These things start to get crazy. And the nice thing about this is we're using both sides, the negative and the positive side, so we can actually get it more and more like a DC circuit in the end. But the biggest thing here is you need to know that diodes are seen useful in their role as converting AC to DC because it prevents that current from reversing direction, keeps it at steady voltage. All right, that's it for today. I'm going to give you another number right here just to add to the end, just to make sure. So again, that first number of the day was 107. If you put a second number in there that is, let's go with 113, you got credit for the day. All right, tomorrow I'm going to go through, I'm going to talk about circuit protection. I think you guys will enjoy that one. It has a lot of explosions and a lot of fun stuff going with it. Have a good night, guys.